Good day, mathletes! Welcome to another day of magnificent, math-exciting, and magical experience in learning mathematics here on TV Eskwela with Christine Joy D. Liquit. Are you ready? Be sure that you are holding your Module 1B for this week, as well as your pen and paper. So listen attentively to follow my discussion. For today, we will explore another factoring technique. But before we start, let us recall pattern to square a binomial, as this is very important in understanding this new factoring technique. Can you still remember these patterns? Are these patterns familiar? Of course, it's from your grade 7 lesson under special products about the square of a binomial. If that's so, let's try this. Fill in the missing term by choosing the correct answer from the choices below the expression. I'll give you 5 seconds for every item. Number 1. Quantity x plus 2 squared is equal to blank plus 4x plus 4. Based on the pattern, we will square a for our first term. Then, what will be the first term of the product? Our a is x. Then, the square of x is x squared. Very good. For number 2, quantity 2x minus 3 squared is equal to 4x squared minus blank plus 9. What will be the middle term of the product? Based on the pattern, it is twice the product of A and B. So our A is 2x multiplied by 3 as our B. We got 6x. And it must be twice. Therefore, we got 12x. Good job! Lastly, quantity 3x plus 4 squared is equal to 9x squared plus 24x plus blank. What do you think will be our last term? 16. Perfect! We got 16 by squaring b, which is 4. Or 4 times 4 is equal to 16. See? The pattern is a great help. Now, you have already remembered how to find the first, the middle, and last term. Then how do you determine the sign or operation of the middle term? Yes, it depends on what operation is being used in the given binomial, as what you can see on the screen. In general, the square of a binomial will give us a result or a product of what? Trinomial. Exactly. Specifically, perfect square trinomial. Is the word already familiar? For today's lesson, we're going to factor perfect square trinomial. Let us be guided by our objectives. Number 1, identify whether or not an expression is a perfect square trinomial. And And lastly, factor perfect square trinomials completely. But before the proper lesson, let me show you a lyrical video from YouTube by Mr. YB that might help you later in determining perfect squares. Read, listen, sing, have fun, and try to understand.
149, 60, 25, 36, and then comes 49, 64, and then comes 81. Now we're at 100 and we are almost done. 121, 144, 169, now we're coming out the door. 196, 225, 256, and now we're coming at you live. Perfect square, perfect square. When you multiply a number by itself, you get a perfect square, perfect square. When you multiply a number by itself, you get a perfect square, perfect square. I used to be cool, but now I'm a perfect square. 149, 16, 25, 36, and then comes 49, 64, and then comes 81. Now we're at 100 and we are almost done. 121, 144, 169, now we're coming out the door. 196, 225, 256, and now we're coming at you live. Perfect square, perfect square. When you multiply a number by itself, you get a perfect square, perfect square. When you multiply a number by itself, you get a perfect square, perfect square. I used to be cool, but now I'm a perfect square. Square, perfect square. When you multiply a number by itself, you get a perfect square, perfect square. When you multiply a number by itself, you get a perfect square, perfect square. I used to be cool, but now I used to be cool, but now I used to be cool, but now I'm a perfect square.
Did you enjoy singing and vibing to its beat? Well, good to know. According to Mr. YB, perfect square, when you multiply a number to itself, you get a perfect square. What a photographic memory! Now, let us test your ability in determining PST, or perfect square trinomial, in the activity called I perfect? Just say P if it is a perfect square trinomial, and N if not. Number 1, A squared minus 22A plus 121. See the patterns. Your first and last terms must be a perfect square, meaning they have positive square roots. So, check for that. And the middle term must be twice the product of the square roots of A and C. So, is it a P or N? The answer is P. Very good. For number 2, 36R squared minus 60RT plus 25T squared. Oh, larger numbers. Again, are the first and last terms perfect squares? Yes, the square root of 36R squared is equal to 6R. And the square root of 25t squared is equal to 5t. multiplied together, we got 30RT. And twice 30RT, we have 60RT, which is exactly our middle term. So the answer is P. Great! Now, how about this third one? 4D squared plus 20D minus 25. Who answered P? Now, who answered N? Are you sure? The correct answer is N. And yes, the terms are completely exact as how it is being described in the pattern. Is 4D squared a perfect square? Yes, its square root is 2D. Is 25 a perfect square? Yes, its square root is 5. Multiply both, we got 10D. And twice 10D is 20D. Now, what's wrong with the expression? Exactly. The patterns of the operations being used. It doesn't match to our pattern. Lastly, E squared plus 50E plus 100. Are E squared and 100 perfect squares? Yes. Multiplied both and twice the product, we got 20E. The middle term is wrong. Therefore, it is a P or N. N. Perfectly done. This time, let us continue the process. For our main topic, let's factor PST as easy as 1, 2, 3. As you said earlier, that the expression a squared minus 22a plus 121 is a perfect square trinomial. The steps that we followed are the following.
So here are the steps in factoring perfect square trinomials. Step 1. Examine whether the first term and last terms are perfect squares. We already examined earlier from the given expression a squared minus 22a plus 121 that a squared gives us the square root of a, and 121 gives us the square root of 11. Therefore, both are perfect squares. Check for step 1. For our second step, look at the middle term. Check whether it is twice the product of the square roots of the first and last terms. Now let's multiply a and 11. Then we got 11a, exactly. Now twice of 11a is 22a. We exactly got the middle term. So check for step 2. For our third step, if conditions 1 and 2 we're satisfied, considering also the operations pattern, then the expression is a perfect square trinomial. Check for step 3. For our last step, factor completely the given trinomial following the pattern. Here you go, that's the pattern. And since our given expression is as the same as pattern number 2, then we have quantity square root of a squared is a minus, since our original expression uses subtraction from the middle term operation. Then the square root of 121 is 11. Then let's put a square. Or we can also have quantity a minus 11, quantity a minus 11. It's just the same.
That's it. Is it easy for you now? Let's have another one. Let's factor PST as easy as 1, 2, 3. The given expression is 4x squared plus 4x plus 1. Remember the steps. Let's start for step 1. What is our first term? 4x squared. Correct. Is 4x squared a perfect square? Yes. The square root of 4x squared is 2x. Very good. Then what is our last term? 1. Exactly. Is 1 a perfect square? Yes, of course. Since the square root of 1 is 1 itself. That's right. Class, I know that you already learned about radicals in your previous grade, and the square root of a positive number can be also negative. But in factoring, let us use the principal square roots, and these are the positive ones. Got it? Okay, let's proceed to step 2. Look at the middle term. Is it twice the product of the square root of our first and last terms? Yes, because 2x times 1, which is the square root of 4x squared and 1, is equal to 2x times 2 is 4x. You got it right. Since it satisfies the conditions as well as the signs, check for step 3. Then, let's factor it completely for the last step. 4x squared plus 4x plus 1 is equal to quantity square root of 4x squared is 2x plus, since the operation used in the middle term is also plus, then square root of 1 is 1, close parenthesis, then squared. Or we can have quantity 2x plus 1, quantity 2x plus 1. And this is our final answer. The factor of 4x squared plus 4x plus 1 is quantity 2x plus 1 squared, or quantity 2x plus 1, quantity 2x plus 1. Great job! Now, we can factor PST as easy as 1, 2, 3. Remember this, class. The steps given are applicable for PSTs only. If what is to be factored out is not a perfect square trinomial, then other possible techniques may be applied. We have a lot of ways in factoring polynomials. But there are some cases, class, in which you need to factor out first the greatest common monomial factor, or the GCMF. That's the first topic in factoring polynomials. Hope you can still remember. So, GCMF first, before factoring the perfect square trinomial. To fully understand this, take this example. The given expression is 3x squared minus 18xy plus 27y squared. At first glance, we cannot find the perfect square trinomial, right? But if we factor out first its greatest common monomial factor, like for 3, 18, and 27 only, since there are no common variables, we factor only for each numerical coefficients. Then, their GCF is 3, since all the numbers are divisible by 3. So let's factor and divide 3 to each of the terms. 3x squared divided by 3 is equal to x squared minus, copy the operation, then 18xy over 3 is 6xy plus 27y squared divided by 3 is 9y squared. Very good. So, we got 3 quantity x squared minus 6xy plus 9y squared as the factor of our original expression, which is 3x squared minus 18xy plus 27y squared using GCMF. Now, looking at the resulted expression inside the parenthesis, we can determine that it is a perfect square trinomial. Why? Simply because our first term is x squared, which is a perfect square. What is the square root of x squared? X. Nice one. Another. Is our last term a perfect square too? Yes. The square root of 9y squared is 3y. Correct. Now, is the middle term twice the product of x and 3y? Yes, the product is 6xy. Now, if that's the case, let's factor the expression x squared minus 6xy plus 9y squared. Here you go. That's the pattern. So let's factor it out. Let's bring down 3 since it's already one of the factors from the original expression. Now, let's factor this PST as easy as 1, 2, 3. The square root of x squared is x. Our expression is the same as pattern number 2. Now let's follow. Minus the square root of 9y squared is 3y. And let's square the factor. So that's it. Our final factors are 3 quantity x minus 3y squared. Or we can have 3 quantity x minus 3y x minus 3y. Did you follow the process? If yes, good to know. If not really, let's factor another trinomial for this case. Given 75t cubed plus 30t squared plus 3t. Oh no, there's a cube there. Don't be bothered. Just put in mind that the higher the exponent and numbers, the more exciting math is. It's an easy one. First step, use what factoring technique? GCMF, since it is applicable. Very good. Then what is the greatest common monomial factor of the given expression? 3t. Great. For 75, 30, and 3, the GCF is 3. And looking at the variables, all terms have t. So, the GCMF is 3t. Now, let's divide 3t. Quantity 75t cubed divided by 3t is equal to 25t. Now what happened to the exponent? Yes, subtract. We have 3 minus 1 is equal to 2. So let's put squared above. Next, plus 30t squared divided by 3t is equal to 10t. And plus 3t divided by 3t is 1. That's it. Now, observe the second factor. 25t squared plus 10t plus 1. Is the expression a perfect square trinomial? At the first 10-second glance. Yes, it is. 25t squared and 1 are perfect squares. And if we multiply their square roots, which is 5t and 1, and then twice the product, we got 10t, which is the middle term. Therefore, let's factor this expression using PST technique. 3t quantity, the square root of 25t squared, 5t. Then the square root of 1, 1 of course. Close parenthesis. What operation must be used? Addition. Very good. Then put squared. And that's the final factor. Or you can have 3t quantity 5t plus 1 quantity 5t plus 1. Is everything clear now? Again, just examine first the given expression. Then check the conditions and factor using GCMF, followed by PST or PST alone, if applicable. Please take note of that. That's it. Now class, if the resulted expression is using GCMF, is not a PST, then do not proceed in factoring using PST technique. Again, there's another technique for that case. That's the end of today's lesson. Now, it's your turn. Break it perfectly. Factor the following completely. 2 points each. You can start answering now. Number 1, y squared plus 20y plus 100. Number 2, k squared minus 8k plus 16. Number 3, 16m squared plus 48m plus 36. Number 4, 49b squared minus 14b plus 1. And number 5, 3x squared y minus 24xy plus 48y. Cool! Secure that all expressions are applicable for PST cases. So, no need to examine. Copy the task first. This 5-item expressions here. But I believe it's already on the module. And our time is running. I will be giving you enough time to factor the following expressions completely. I am expecting that you are already in number 3 right now. Be sure to apply the technique properly and always remember the pattern. Don't forget the pattern class. All the patterns that have been taught are very important in factoring polynomials because some expressions are applicable for multiple techniques. Just like what we did earlier. We do GCMF first before PST. Techniques are indeed helpful. Techniques are important class because these are learning strategies. Learning strategies in which there are steps taken by you, by us, to enhance our own learning. That's how techniques work. Are you doing good in factoring the given trinomials? Is it easier to factor now? Then, are you excited to check your answers? Take your time. Do not hurry. Check your work. Check the process. Double check the square roots. Recheck also the operations being used. And kindly check the squares. I am pretty sure that many will have a perfect score. Factor PST as easy as 1, 2, 3. Are you still good? Are you still comfortable in your place or in your position? Keep your mind and body relaxed for you to think clearly. I'll be showing again the given expressions. Kindly recheck first to assure that it was copied correctly. If you're doubtful in regards to your answers, just multiply again the factors. If the result will be the original expression, then you got it correctly. Are you done answering and ready for checking? Then, let's check your work. Let's start with number 1. Y squared plus 20y plus 100. Now follow the pattern. Quantity, the square root of y squared is y. That's it. Now what operation must be used? Addition, exactly. Now the square root of 100 is 10. Very good. Then put squared. Now our final factor is quantity y plus 10 squared. Or we can have quantity y plus 10, quantity y plus 10. Now let's proceed to item number 2. We have k squared minus 8k plus 16. Again, follow the pattern. Quantity, the square root of k squared is k. Now what operation must be used? Subtraction, exactly. Now the square root of 16 is 4. Now let's put an exponent of 2. Now our final answer is quantity k minus 4 squared. Or we can have quantity k minus 4, quantity k minus 4. Great job! Let's proceed to number 3. 16m squared plus 48m plus 36. Now observe the expression. Can we use another factoring technique? Yes, of course. Let's do the GCMF first. There is no common for the variables, so let's find the GCF of 16, 48, and 36. And what will it be? Who answered 2? How about 4 or 8? Are you sure? Okay, the GCF is 4. So let's divide each term by 4. Quantity 16m squared divided by 4 is 4m squared. Copy the operation plus 48m divided by 4 is 12m plus 36 divided by 4 is 9. Very good. Now we already factored the trinomial using GCMF. We got 4 quantity 4m squared plus 12m plus 9. Now our second factor is a PST or perfect square trinomial. So let's factor it again. Copy 4 for our first factor from the original expression. Now remember the pattern. Now quantity, the square root of 4m squared is 2m. What operation must be used? Addition, exactly. Now the square root of 9 is 3. Very good. Then put squared. Or we can have 4 quantity 2m plus 3 quantity 2m plus 3. Good work! For item number 4, we have 49b squared minus 14b plus 1. Now let's follow the pattern. Quantity, the square root of 49b squared is 7b. Now what operation must be used? Subtraction, exactly. Now the square root of 1 is 1 itself. Very good. Then put squared. Now we have quantity 7b minus 1 squared, or quantity 7b minus 1, quantity 7b minus 1. Very well. Now let's proceed to our last item, number 5. We have 3x squared y minus 24xy plus 48y. Observe the expression. Can we use another factoring technique? Yes, of course. Let's do the GCMF first. Now, there's a common factor for the variables, which is y. Then let's find the GCF of 3, 24, and 48. And what will it be? 3y. Perfect. So let's divide each term by 3y. Quantity 3x squared y divided by 3y. We have x squared. Now copy the operation, subtraction or minus 24xy divided by 3y. We have 8x plus 48y divided by 3y is 16. Very good. Now, we already factored the trinomial using GCMF. We got 3y, quantity x squared minus 8x plus 16. Our second factor is a PST, or a perfect square trinomial. So let's factor it again. Remember the pattern. Copy 3y as our first factor from the original expression. Then quantity, the square root of x squared is x. Nice. The square root of 16 is 4. Very good. Then put square. Perfectly done. Or we can have 3y, quantity x minus 4, quantity x minus 4. Now who got perfect? Very good. For those who got wrong answers in some items, don't worry. For sure, that doing it next time will be easier. So now, we can factor PST as easy as 1, 2, 3.
Congratulations! I think we deserve to congratulate ourselves since we do a great job. I hope that you learned a lot. Kindly answer the task given to you by your subject teachers. Factor PST like a pro. That would be all for today. Goodbye and have a nice day, mathletes. Make TV Escuela a weekday educational habit to help you in understanding the module content. Again, this is Miss Christine Joy D. Liquit, your math teacher for today in factoring perfect square trinomials. Class, remember that life is not always perfect. It isn't always easy, but it's yours to live. Just always remember that when it gets hard, it's never as bad as it seems. Be thankful of what you have and live life to its fullest. Well, see you into our next episode of Magnificent, Math-Citing, and Magical Experience in Learning Mathematics. Remember, dito sa TV Eskwela, sa pag-aaral, sama-sama. Bye-bye!